Hello, everyone. It's good to be here in another reInvent. My name is Amir, and I'm here with my dear friend and colleague, Venkat. Wave. So, for those of you who've been listening, there's been a lot of interesting announcements lately. And one of those announcements were about Systems Manager, AWS Systems Manager, a new service to help you gain operational insights and take action against your resources and applications. Now, the premise to what we've done here is pretty simple. We know that operating an application is a hard job. We know that doing it right and at scale is even harder, because a lot of us have to make mistakes to learn, to get better over time, to iterate. Now, this is one of the reasons we released Systems Manager, so you, our customers, can learn from our collective experience of how we do things internally and make as few mistakes as possible. Be better. Now, how did we get to building this? As you probably know, Amazon prides itself as working backwards from our customers. And by talking to you, our customers, we've recognized three common themes or repeating challenges that kept coming up in virtually many conversations when it came to operations and managing applications on AWS. The first one being, what resources make up my application? When I build an application on AWS, it is powered by many services, individual services, AWS services, that have their own respective resources, which you provision when you build an application on AWS. Mapping which resources match your application is somewhat of a challenge. The second challenge that kept coming up was, assuming I know which resources make up my application, how do I make sure that these resources and subsequently my applications are healthy, right? Usually the insights or the metrics or whatever metric I'm looking for to find out if my application is healthy is in a respective service console that is that of the service that is powering my application or is a part of my application. Customers kept looking for ways to find out those insights, to gather those insights from a centralized location. The third one is, assuming I know something is wrong, let's say my application is no longer healthy, how do I take action and to make sure my application gets back to a healthy state? How do I recover what needs to be recovered? How do I make a change or apply a change across multiple different AWS services that, again, all have a part in my application? Whether I use a serverless architecture or a server-based architecture, how do I make the best use of my resources in AWS and make sure they stay healthy? We grouped all of these together under what we call the pursuit of operational excellence, which is what we also pursue internally, which is the process of iterating until you become better at doing your operations. Operate safely and at scale. Systems Manager is here to help you shorten the time it takes you to detect a problem and the time it takes you to react to said problem. Now, it does this by providing a collection of tools for both reactive and proactive action. Now, to map what we heard from you to solutions, or let's call them building blocks, we've discovered that by grouping the building blocks of your applications, identifying what resources make up your application, by being able to augment those resources that make up your applications with relevant insights, and by providing the necessary and respective tools to act against those collections of resources, and again, to make sure your application stay healthy, we get to a place where we can start claiming we have operational excellence, where we pursue operational excellence, where we get better. The first of these building blocks is resource groups. Now, for those of you who might know, resource group is an existing service which we re-announced, resource groups v2, AWS resource groups, which comes with a new console, a new public API, and is heavily integrated into AWS Systems Manager. Now, using this new service, you can search for AWS resources based on their type and a matching tag key value. So I can say something like, give me all EC2 instances, all Lambda functions, all S3 buckets, ELBs, RDS databases that are tagged with production or environment equals production. I can then go ahead and save that search as a resource group. Now, it is actually a dynamic resource group. The reason I say dynamic is because applications are a living, breathing thing. They change over time. Those of you who use services like auto-scaling groups know this. An application keeps changing, keep evolving. New resources get added to that application over time. So when you actually save a search query that has those resource type and the matching tag criteria, you're actually saving that rather than the list or the output, the list of resources. I'm going to quickly demonstrate how this looks like. I'm in the console home where I can see Systems Manager under Management Tools. This is the welcome page, and I can expand the left navigation where I'll see resource groups. As I mentioned before, this new service comes with a new console, a new API, and is integrated directly through Systems Manager. Here I can click Find Resources. Let's say I'd like to search for all EC2 instances, load balancers, and let's say RDS databases that are from my production, from my test environment. View query results, and I get the subsequent list of resources that meet that particular tag criteria. I see the name of the resources, their state, the service that is powering them, their type, and assuming they have an ID, an identifier. And then I can optionally save this result as a resource group. And again, I'm saving the query itself, which every time I run will give me the most up-to-date view into my application. Now, when I save a resource group, I give it meaning. I give those resources meaning, which could be anything, like an application component, a tier in my application. They can represent an environment. It's up to me to give it meaning. I can also do something like tag that particular resource group. When I tag a resource group, I essentially say that this resource group is a part of a larger whole. So this resource group could actually represent the front end of my application, but while still being a part of a bigger whole, which would be my mobile application. Now, when I hit create, as I mentioned before, I'll be saving the tag criteria rather than the result set. And when I hit Saved Resource Group, I can see all my respective resource groups that I've sent in the past. Again, every time I use it, I'll get the most up-to-date list of resources that are a part of this application. Once I have a group, I can start augmenting it with insights and take action against it, which we'll show in a little bit. Now, as a part of the insights I can get on a resource group basis, we have our integrated cross-service insights. Now, these include multiple services. Amongst those services, we have CloudTrail. Now, for those of you who are not familiar with CloudTrail, it's a service to track API activity history. With CloudTrail, I can track API calls that were made through the console, the SDK, command line, and even other AWS services. So if a service like Elastic Beanstalk makes a call to EC2 to stop an instance on my behalf, in CloudTrail, I'll be able to see those API calls and, of course, the fact that Elastic Beanstalk had made them on my behalf. Now, to give you an example of what sort of situations I'll use CloudTrail, imagine that I'm a part of a development group. And we usually operate in North Virginia, the North Virginia region. And at some point, while browsing for the console, I navigate to the Sao Paulo region. which is a very nice place to be at. But what I notice is that there are 32 new instances that I did not provision, and I'm not actually sure who did, which merits an investigation. Through CloudTrail, I'll be able to see which IAM user provisioned those instances and when exactly did that happen. And of course, continue my analysis. So I'll use CloudTrail to do security analysis, to track changes, and to troubleshoot. In addition to CloudTrail, we also integrate with config. Now, config is used to track configuration changes of your AWS resources over time. Now, these may include state changes to the resources and also attributes. As an example, let's go back to the part where I'm a part of a development team. And we actually have a very, very strict tagging criteria or tagging practices in our org because we build our automation on top of tagging and our permission models. So every time somebody changes a tag of a resource, that's a big deal for us. So let's assume by navigating through config, I see that a particular set of EC2 instances had their tags changed multiple times across the past day. Now, this may be a reason for concern, but what I'll be able to do is track those changes and then use something like CloudTrail to find out who was the one that actually made those changes and to see if this was done by design. Now, as I mentioned before, these are insights that you can get on a resource group basis, which we'll demonstrate in just a little bit. In addition to those, we also integrate with Personal Health Dashboard. Now, Personal Health Dashboard gives me performance and availability insights of our AWS services. So if a particular AWS service is experiencing performance issue, Personal Health Dashboard will be where this will be presented. In addition, we also have an integration with Trusted Advisor, which I trust some of you are using, or should be using at least. With Trusted Advisor, you can get real-time guidance and recommendation on AWS best practices where it comes to cost optimization, performance optimization, and security recommendations. Some examples of the insights you can get from Trusted Advisor is your security group actually has a surplus of ports compared to the ELB, which is a part of it. So perhaps it would be best for you to match the open ports that you have in your ELB to the ones you have in your security group. And you can get cost optimization recommendations like you have EBS volumes that are not attached to any EC2 instances, which means they are candidates or potential candidates for termination, assuming they are idle and we're not using them. In addition to the integrated insights we offer systems through Systems Manager, we also have the ability to track your software inventory and compliance. Now, through our inventory capability, we let you track your software catalog and configuration. This effectively includes all the application packages, the file metadata, network configuration, and OS details of your instances. Now, let's assume I want to make sure that a particular software package is installed on my fleets of instances. Inventory would be the place to do that. In addition to inventory, because we know or we can track what is installed on our instances, we can also define what is considered compliant behavior. So if I want to make sure that a particular version of Ruby is something that is considered compliant for me, I can define this as a rule. And then I can notice through our dashboard whether there is a deviation or a drift from that compliance criteria. In addition, all this is integrated with config, so I can see the state changes of the software on my instances over time, which looks somewhat like this. In this example, these gray boxes represent different state. So I can see that in a span of 30 minutes, the software on my instance changed multiple times, and I can keep track of this through config. In addition, I can also export all this information to S3 to do later analysis through third-party tool or built-in tools that I use in-house. And now I'd like to demonstrate how this looks like in our console. So I can, as I mentioned before, once I create a resource group, I can navigate from that resource group page to gain insights. And I'll start with the built-in integrated insights. Once I select the resource group, in this case, the front-end resource group that I've created, I can see something like config rules. Now, config rules, just like the compliance that I've mentioned, are my means to define what is considered a compliant behavior. For example, let's assume that I define a config rule that says all my AMIs on my Amazon Linux instances have to be of match a particular AMI ID. And that is what I define as compliant behavior. Assuming that is not met, I'll see this on a resource group basis in this page. So in this case, I see I have 6 compliant resources and 1 non-compliant resource on this particular resource group. When I navigate here, I can see that I have a bucket that is actually not compliant. When I click this, I'll be dropped down in the config console, where I can actually see why is it not compliant and remediate. In this case, I see versioning is not enabled on this S3 bucket. So now that I know what the problem is, I can, of course, remediate. And remember, you can define those rules by yourselves. In addition, I can see the configuration changes over time. So while I see most of my resources in this resource group have changed only once, I see my VPC has changed its configuration multiple times. And again, I can drop down in config to see this state changes over time. With the integration with CloudShell, we can see the most recent API calls that were made to the members of this particular resource group. And again, I can drop down in CloudShell to get additional insights. When I'm here, I'll have already pre-filtered that particular resource that we tracked, and I can see all the API calls and who made them for this particular resource. In this case, I can see that this instance had tags created, was rebooted, and I can even see that another AWS service, in this case, OpsWorks, had made calls on my behalf to change the state of the resource. In this case, it registered it with an Elastic Load Balancer. And again, remember, we're still in the same console experience of Systems Manager, where I can get the high-level insights that get me to the right places as fast as possible in order to find problems as quickly as possible. As I mentioned before, we also have Personal Health Dashboard, and right now I can see there's no issues with AWS services, which is a good thing. And Trusted Advisor, where I can see the summarized highlights of the recommendation, an aggregate of those recommendations, and of course, a link into Trusted Advisor to get additional details. As you can see, cost optimization, performance, security, fault tolerance, and now also service limits. In our inventory view, we can see a summarized list of all the packages that are installed in our instances and their configuration. We even have a search to run queries against that inventory. Now, you may be asking yourself, how can we know what is actually installed of those instances? Which is, by the way, not just EC2 instances, but also on-premises servers. Now, the way we do this is by using our service agent. The AWS Systems Manager service agent, which is open source, is how we gain those insights. And as I mentioned before, it's open source, so I welcome you all to go and have a look. In addition, as I mentioned before, you can also define whether this is considered compliant behavior. So if a particular patch or a particular software package or configuration is considered compliant in your perspective, you can define this here and, of course, get a dashboard view to see if you're indeed compliant. Now, there's no pursuit of operational excellence without having some operational dashboards, which is why we also integrate with CloudWatch dashboards. With CloudWatch dashboards, you can display multiple metrics, which include infrastructure metrics like CPU, memory, process count, and even application metrics, your specific application KPIs, what is important to you. You can also customize them with text, images, whatever you like. And in addition, you can build multiple dashboards, not just a single dashboard, with distinct views into your environments. So a dashboard could represent a tier of your application, an application component. It can also represent an environment, whatever makes sense for you and for your business. You might design your dashboards based on the team structure, based on the architecture of your application. It's up to you to define how this looks. And good news for all you existing CloudWatch dashboard customers, because you can reuse all of your dashboards as is, no changes, directly through Systems Manager. Let's have a look at how this looks like. Starting with CloudWatch dashboards is very easy. All you have to do is click Create Dashboard, enter a dashboard name, create, and you got your dashboard. Now, this dashboard is a canvas. Do with it what you like. As I mentioned before, text, images, metrics, application metrics, whatever is important to you from an operational perspective gets into that dashboard. And these are completely customizable, as I'll show you. Let's pick an existing one that I've created in Advanced, which is more interesting and colorful. So you can see here, I have a dashboard that represents the same applications that we've been going through, the same resource group, the front-end fleet. And here I have interesting metrics like a request count versus process count. I have request count versus versus the request count, processes, CPU usage, memory usage, and again, as I mentioned before, this is completely customizable. I can shrink this, I can move these, I can very easily add more by clicking Edit Widget. There's even multiple types of different widgets. I can even get a sneak preview of how this dashboard would look like in here. So when I select my metrics, I'll have a brief view how they look like before I approve them. And of course, there's a lot more. I can change the span of which I see here, the span of time. So right now we're covering 1 hour, but I can easily go 3 hours, 12 hours, 1 day, and more. In addition, you have full control on the refresh rate of how often these are refreshed. Right now it's set to 10 seconds. So again, you can customize this how you will, and just click Save Dashboard, and that's it. And as I mentioned before, you can have multiple of these representing multiple facets of your application or your environment, whatever makes sense for you. Now, when you're trying to troubleshoot an issue, notice that this line will go with you. If you notice, this line is matching itself across all the graphs. So if you're trying to troubleshoot a particular operational issue, this will be tracked through this graph. Well, you'll see how this correlates across multiple metrics. Now, for our discussion purposes, let's assume that for now, just for this time, I don't work for Amazon, and I'm a part of a 10-person team that operates an application, a web application. Now, our customers and partners have been reporting problems ever since this morning. But I also know that we deployed a new artifact, a new version of our application also early this morning. Now, our team is not yet sure there's a correlation, and they've asked me to investigate. They've asked me to have a look. Maybe I can help them out. Maybe I can tell what went wrong, and if it's indeed related to the deployment of this new artifact. Now, the team can just roll back the new artifact. They can roll it back. But our team is very cautious about making any changes to our production environment because the team has made some mistakes in the past. So unless the team can verify with high certainty this will actually solve the problem, the team is very shy from doing this. So when I investigate, I'll probably go and first have a look and config to see if there's any state changes to the fleet, aside from the ones that I already know of, the one that I can map to. I'll probably then navigate to CloudTrail to see if anyone has made any recent API calls. I look, and I don't see. Then I navigate to personal health dashboards. Maybe there's an issue with an AWS service, but nothing there. And then I get to my CloudWatch dashboards, in particular to the front-end dashboard. And I do indeed see something interesting here. The blue line here represents the request count, while the orange line represents the error count. So I indeed see there is an increased error rate ever since this morning. Again, it's now my job to find out if it's really related to the deployment of the artifact. But I'm going to probably need to involve another team member to do that. I'm also looking for a way, a creative way to buy my team some time while they're still investigating the issue. Again, we're very, very shy from making any changes to our production environment. At this point in time, I'm going to pass it on to Venkat to see if he can help me out.
Thanks, Amit. Thank you, Amit. Can you folks hear me?
That doesn't count.
All right, great. Thank you, Amir. So as my friend and team member explained, this is a situation where we want to take an action on a set of grouped resources that are correlating to a behavior pattern. And we do want to deploy a new application, but we want to be cautious. So what we really want to do is, how about we try to restart the node and see if the correlation goes down and buys us some time, right? That's what we figured. So, Amir, I have a solution. I think when we restart some of these nodes, the correlation does go down, so the team gets a little bit more time to investigate the root cause. Before I do that, how do we get there, right? We have a service called automation. This is a Systems Manager service. It was part of the EC2 Systems Manager, now AWS Systems Manager. We have newer features here. For doing reactive operations against your resources and doing proactive operations against your resources, you can do this. Right now, we are in a reactive mode in this example, right? We're going to take some action. Because services are, the ASM services are integrated with deeply integrated resource groups, you can take action, as you can see. Actions like, as you can now see, right. As you can now see, you can take a bunch of actions. I will not go into all of them right now. I'll talk about automation. You can take an action using automation. What is automation? Automation service lets you create a set of steps that you otherwise do manually or write some scripts. You can take those steps and sequence them and have them be executed as one document, as one action. And you can define steps that can perform a variety of operations across your AWS resources. Automation also helps you manage your resources in a deterministic way. You can take automation and say, I want to run one step at a time. You can run it in a bulk way. More importantly, you can take some safe operations. I will show the safety part as part of the example we've been talking about. You can take an automation and say, I want to execute this automation against a resource group that probably has like 10 instances. You can say, I want to run this automation against this resource group for 2 instances at a time. And I want to stop this automation at any error threshold you define. You could say 50% of failures, or even a failure is reported, you want to stop the automation. So now we have a set of deterministic actions that have been grouped together in automation that you can perform against a known set of resource groups, and you can perform them safely with error thresholds and velocity control. You can also constrain your automation. For example, if a user in your account should not have access to perform an operation on a resource, but requires to do that, instead of providing that user a direct access to the resource, you could delegate that process by using an automation. You can use a role that has access to perform that operation. You can use that role, embed that role in the automation, and all you need to do is provide that user an ability to execute this automation document. Now, what it does, it helps you delegate administration. It helps you lock down your resources. It also helps you track, like we mentioned earlier, the trail, the cloud trail. You can see who did what. Now you can not only constrain, you can perform safely. You can see who did what at what time. That's what automation helps you do. And because we are in the example here, I am going to switch back to my demo and show the demo part of it. All right. So Amir, you told me we need to take an action against this automation. So I'm going to switch to a different view here. If you notice here, I'm an application operator. That's the persona I'm assuming now. I'm going to, by the way, here's where you find us. As an application operator, I'm going to look at my available operations. I have a list of automations here, and I'm going to go to this resource group that Amir pointed out. Remember the front-end mobile application? We said we're going to try an automation here, which will help us buy some time. There's a list of inbuilt automations. I can also write my own custom automation that can show against the resource group. Here, I'm going to take this particular automation. I want to say I would like to restart the node against this resource group. And I'm going to go here and say, all right, at this resource group level, I would want to target all the instances. And I would like to execute this with some error thresholds. For now, I'll leave it as this. You can pick and choose saying how many targets you want to run against. I want to execute this automation, which basically goes after triggering the restart node operation against every resource in that resource group, in this case, the instance I picked. It's going to run this. It's going to take a couple of minutes to restart all the resource groups. So I'll go back to the CloudWatch dashboard and show you how the correlation has changed. Meanwhile, I'm going to show you something else, which is the list of available automation documents. We have shipped a bunch of automation documents that you might find value out of the box. Simple things like restarting EC2 instance. Of course, you could have a user do it, or you can have an automation document that can do that with an approval workflow. Because automation has an approval workflow in place, you can allow users to restart instance after they have requested this approval via another user who's probably an administrator. In this case, I'm an HR app operator. Anytime I restart an instance, I could be told, you can do that, but use the automation document, which will send a notification. In this case, Amir, my HR application owner, he can approve that. And after the approval workflow, the automation continues and restarts the instance. You have a set of automation documents here. There are a couple of interesting automation documents as well, what is shipped. You can bake an army. This is familiar to some of you. There is an automation that you can use to bake custom armies. You can take this automation document and provide it an army ID. You can point it to a pre-installed script, a post-installed script, a cleanup script. You can harden your army and deliver a golden army in one click. This automation works for both Windows and Linux. You also have another automation that rescues your instance. A lot of times customers tell us sometimes their instances go unreachable because the IP address is misconfigured. So this automation in one click, you can provide it an instance ID. It'll go after repairing instance and bring it back online. So automation, as you can imagine, you can put a sequence of steps, your own steps or custom steps, and put them together and execute them deterministically. Let's try and go back to see whether our other automation that we executed against the resource group delivered all right, this is the group. So as you can see, the automation worked, and the nodes got restarted. Like we suspected, we got more time by restarting the nodes. The error count has started going down. So Amir, we gave back you some time, so you can go back and figure out how to fix this application, and we did that deterministically. All right, let's look at one more automation as an example. A feature in automation lets you execute things step by step. How many of you here have live site operations going on? All right, I see some hands. So in a live site environment, typically we follow a 2% rule. You want to execute something, you want to make sure somebody else verifies it, and if you want to take an action, which is a reactive action sometimes, you want to make sure that this is done in a methodical way. You could create runbooks with automation that provides your organization an ability to follow a very strictly guided set of actions that your live site operator will take should a situation arise. I'm going to show an example where I have a bounce host application, right? So let's say in my HR application, there is a situation where I need to bounce some hosts. I'm going to say, all right, I want to execute this step, and I want to execute this manually, one step at a time. I can say, all right, Amir, you're the person that's going to get an email notification because this automation is going to ask me to do that. I'm going to click this and say, all right, this predetermined set of runbook helps the lifesite operator perform a set of steps that they have to follow before they bounce a host. In this case, it's wired to say, every time I run this runbook where it bounces instance, I want to send a note to my lifesite owner. I'm going to switch a window here and show that. If you see an email notification just came because the runbook said, click that button first before you can even bounce the host. It sent a notification to my lifesite operator. I'm going to restart Apache servers. All right. Then I can go after restarting the instance. Then I can send a completion email saying, all right, I restarted the instance. The instance came back online. Everything looks good. So I complete the email. I can send a note. Or if things don't look good, you now can go back and send a note saying, hey, things don't look good. Now, what it does as an application lifesite owner is they can go back to the automation and the history of execution and find out which operator performed what and what happened during that time. So this is another reactive operation you can perform with automation. All right, let's switch back to some proactive actions. Day-to-day operations. Sometimes you want to be more proactive. You write automations that you want to execute. You want to take actions against your host. This is where I'm going to introduce a whole bunch of new services that we have in Systems Manager. Sometimes you want to patch your instances, well, all the times if it's Windows, right? So you want to patch instances and you want to have an opinionated way of patching instances in your organization. So you create an automation document that can perform that. But you can leverage the patch manager service, which can execute patches against it. It's a patch manager service, we can talk about that. You also want to do that in a non-disruptive way. Organizations pick their own maintenance windows. So we have a service called maintenance windows, which lets you pick during what time you want to perform. Maybe Sunday between 12 to 2, you want to execute a set of automations that end up patching your instances one at a time. So you can take the maintenance window, create some automation that calls the patch manager service, and execute this one at a time. Remember, at the resource group level, you could say HR applications get patched Sunday between 12 to 2, and they get patched only after some approval workflows. Now you can put this together and have some IT administration that's well automated and within swim lanes. You can also do, with run, there's another service called run command, which lets you eliminate host access. How many of you here constantly need an access to your host directly? All right, I see a bunch of hands going up. What if we told you you can eliminate host access and still perform what you want to perform on the host, but in a very auditable, very controlled fashion? So run command lets you do that. Like Amir mentioned, we have an agent in the guest. With run command, you can execute commands against remote instances. You can eliminate host access. You can eliminate your bastion hosts. You can eliminate SSH access to those instances and execute run command with tight controls. You can say which user gets to perform what kind of command, and run command will execute that based on IAM roles. You can also hook it up with CloudTrail. You can see what's going on, who did what. And you can also constrain run command by providing some administration on top of it. Another part is run command also do velocity control. You can fan out, you can perform the same command against 1,000 instances, but you can perform with velocity and safety controls in place. Let's go back to automation because I want to show one more demo. Let's switch here. All right. I want to, say, patch a set of instances, and I want to patch it only with some approvals in place. I have an automation document which is going to patch a set of ASG instances. Autoscale group, you have a set of instances. There's always a need to go patch them. You want to patch them one at a time. And this automation document can help you do that. You can write your own custom document as well. You can take this document. In this case, I'm going to say, all right, I want to execute this. I want to enable rate control against this. And I want to say execute against this autoscale group and against a bunch of instances. And I also want to say this approver here needs to approve before I patch. So I have set up some SNS topics here. So what happens when I execute this automation is automation sends a note, sends topic notification to the approver. The approver can log on and say, all right, I approve this operation. And then automation continues, patches every instance in the autoscale group. And if it fails, it stops, and you can go back and look at what failed. So that's the other automation I want to talk about. Well, that brings me to the end of the automation features I want to talk about. So I just want to do a quick recap. You can take a set of steps, put them together. You can execute with constrained delegation model. You can use approval workflows. You can do velocity control, and you can perform against resource groups safely, which brings us back to the resource group construct. Because you're able to regroup and put a set of different resources in homogeneous groups together, you can now create your own automations that belongs to your environment, that is meaningful to your applications, and perform against those resource groups. Let's switch back to my presentation. We spoke about run command, we spoke about patch manager, we spoke about maintenance window. The two other services I want to talk about. State manager, the service that lets you apply states, that desired state repeatedly to your instances. You can define, for example, a particular version of a component must be present on an instance. And you want to make sure that if somebody reverts that, applications don't get broken and you don't get tickets. You can create state manager associations and say this state needs to be repeatedly applied on schedule against your instances, and state manager will do that for you. The other service is parameter store. As the name implies, it is a store that lets you store parameter values, which are key value pairs. You can store plain text, you can store secrets, you can store certificates, you can also encrypt against KMS keys. You can store your values in hierarchical fashion, and you can provide users access to a single hierarchy or a particular parameter. You can provide permissions at the entire parameter level or at a node level. Now, with parameter store, you can also do a couple of things. You can set up notifications on top of it, so anytime a parameter changes in your environment, you can react to that by triggering an automation workflow that does something else on your environment. Example, a database string changes, a connection string. You store this in the parameter store. What it helps you at the high level perform is a good hygiene of separating configuration data from code. Because you now have separated your secrets and config data and store them separately, you don't have to recompile your applications, and you can now control access to this environment. You can change the database string on your parameter store, and your applications no longer have to be recompiled. They look it up, right? That's parameter store. That brings me to my part of the presentation. I'll hand over to Amit shortly. These are the set of customers and partners that are already using Systems Manager today and at scale. They are managing thousands of instances, and they are performing a ton of work with Systems Manager. Off to you, Amir.
Thank you, Venkat. So, as I mentioned before, the premise is simple. We group what we care about. We define how these collections of resources, heterogeneous resources, map to our application, front end, back end, an application tier, an application environment, whatever this means for us, right, in our business context. We then augment them with insights. We visualize them with CloudTrail insights, config insights, personal health dashboards, trusted advisor. We also give you some native insights, which lets you collect the inventory from your actual instances, EC2 instances, and on-premises servers, in case you have a combination or using hybrid. And once we let you visualize all this information, we also give you the ability to create your own dashboards. And again, those of you who are using CloudWatch dashboards, you can reuse your dashboards, and those of you who don't, there's still time. After you gain your operational insights, you can detect problems faster, a lot faster, because you have to look in less places. All of your insights are centralized in a single console experience. And then, if you find that something is wrong, you indeed are experiencing an operational problem, you can take action using the collection of tools that we offer directly through Systems Manager. All of our native capabilities, ranging from automation, run command, state manager, and of course, additional services like parameter store. At this point, I would like to thank you and welcome you to join us in the pursuit of operational excellence. Thank you.